Alright guys, our second lesson this morning is on inscribed angles. We are trying to figure out how is the measure of an angle inscribed in a circle related to the measure of its associated central angle.
I can take pictures of this?
Find the measure of an inscribed angle and use inscribed angles and their properties to solve problems. Key terms are inscribed angles, intercepted arcs, and subtends. We're going to move on. If you need this one, I'll get back to it. Alright, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So we got a big thing here. Central angles versus inscribed angles. Guys, woo, this is the big one in this unit, okay? Central angles
is in the center.
Are where?
In the center.
Very good. They're in the center. And how do we create them? What?
By using the center point.
How do we create them? Two what come together?
Radii,
right? Radii meet. Okay? Inscribed angles. With inscribed angles, okay, they're not on the center. They're going to be on the
inside.
No, the rim. Okay? They're on the rim or the edge of the circle.
They're on the crust.
And hopefully by the definition you can tell these are when what parts of the circle are meeting?
The
chords. The chords create inscribed angles. The reason why that's really important.
You supposed to drop the bottom part.
Yeah. No, you write all of it. Okay? Here is why it's really, really important. Central angles. Central angles end up being so that your central angle is congruent to your arc measurement. That says measurement. Okay? But inscribed angles, this is where the kicker is. Y'all ready for this?
Nope. You broke it.
No,
Broke it.
Now buy him a new one.
This thing was like $17.
Inscribed angles, check it out. Inscribed angles are 1/2 the measure of the arc measurement. Okay? And you'll see what I mean when I say that in just a second. Okay? Alright. Intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. See what this looks like. Precisely what I just said. DEF is an inscribed angle. DF is what we call the intercepted arc, and arc DF subtends angle DEF. Okay? Now, here is the inscribed angle theorem. Just need to write down this part. The measure of an inscribed angle is half the measure of the intercepted arc. Right? The measure of inscribed angle is 1/2 the measure of the intercepted arc. Got me? They give you 3 cases here. ABC, where BC is the diameter. ABC, where it's not. ABC, where it's just regular. Guys, the easy thing to do, think about this. If you have radius meeting together, that's a central angle. If you have chords, that's an inscribed angle. That simple. Keep it that simple, right? Okay? Alright.
You know this one that they got up to like 9,000 RPM?
Alright, let's look at this real quick. Find each measure. First off, you got to be able to go 2 ways with this, guys, okay? If you're going from, this is asking for the measure of angle PRU, so I'm asking for this particular angle measurement. Remember, if you're going from arc down to angle, you're going to divide by 2, right? Arc down to the angle, you'll divide by 2. That's how we get 59 here, okay? Think about it. Same thing here, right? I go from arc down to the angle, I divide by 2. But the second question says, what's the measure of arc SP? Well, if you go from angle out to arc,
You multiply.
you'll multiply. What's 27 times 2?
54.
67.
54. Okay? Y'all see the difference there, right? So you can't just sit there, because a lot of people get confused with this, and they'll take really wild guesses, and they'll be like, oh, I know it's inscribed, so I divide by 2 every time. Hold on. Pause. Got me? Pause. Wait a minute. Only when you're going from arc down to angle do you divide by 2. If you're going from angle up to arc, you multiply by 2. Okay? And literally, that's about as hard as I can make this. Okay? Okay? So, check it out. That's about as tough as we can make it. How would we find the measure of ADC? Oh boy. Check it out. Okay? We know right now that all of this, ADC, right, that entire thing is going to have to be how much?
360.
Yeah, well, no.
Well,
ABC is 135 degrees, right?
oh,
So that means that all of this, A to D to C, that whole thing is going to be 135 times 2, right? 135 times 2 is 270. So the whole thing would be 270, okay? From A, D to C. You'll see how I do that?
yeah. Wait, so wouldn't AD be 170 something?
If
Oh, gosh.
ABC, you see how these are chords right here, Gordon? AB and CB are chords. Remember, if I go from angle out to arc, I gotta multiply. Okay?
Okay.
Alright? What if I ask for the measure of angle A? What would that be? What am I gonna do there?
30.
38.
38.
Go 76 divided by 2, right? You'll see the difference there? Again, that's about as hard as I can make these things. Alright? Oh, just kidding. Alright. If inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. You know what? Guys, you don't even need to write that down. You don't need to write that down. Let's just look at this real quick. Okay? Alright. What you want to look for is what I call the parent arc. Okay? When I say the parent arc, here's what I mean. AB has a whole bunch of chords that shoot out from it, right? Let's just look at this real quick. You got A to C, you got A to D, you got A to E, then you got B to E, B to D, B to C, correct?
Yeah.
Really and truthfully, the parent arc here, I think, is AB, okay? All right, so with that in mind, think about this. If I told you that AB was 100 degrees, take it case by case. Is ACB, is that an inscribed angle?
Yeah.
Yeah. Are inscribed angles 1/2 of the intercepted arc? That means that angle C is 50, right? Okay. Is ADB an inscribed angle?
Oh, it's going to be 50 also.
Because it's still 1/2 of the intercepted arc. And is AEB an inscribed angle? It is, right? You'll see what I'm saying here? That's why the theorem, it looks crazy, okay? But it's really not as bad in practice as you would imagine, okay? They will do crap like this to you sometimes. We're not going to do this problem, but I did want to show you at least so you have a visual of what may happen, okay? You have a whole bunch of stuff here, right? Check this out. CB is 164 degrees. Okay? CD, BD, CE, BE, CA, BA. All of those angle measurements are going to be 1/2 of 164, right? Okay? So if you ask for angle DFA, what you're going to end up doing is you're going to end up finding what these arc measurements are that accompany them and go from there. 150. Okay, we'll get there later. All right. All right. Let's use our noggins here. If you have a semicircle, is this? You know what? I don't think I've asked this yet. Is this a central angle? Yeah. It's weird, right? Why are you saying yes, Hannah? Because it's what? Yeah, it's the center of the circle, right? It still meets our definition of two radius meeting together. Hannah, it's kind of strange to think about.
Oh, it's just
That's a 180-degree angle, right?
That's just like a really big.
If that central angle is 180 degrees, what is this arc measurement out here? 180. And then, oh, sensei, I have chords that shoot out from that particular semicircle, okay? And now they form an inscribed angle that is exactly 1/2 the measure of the arc, right? See how all that worked? So if you get a diameter, here's what you better do, yo. What would I set 5a plus 20 equal to here?
90.
90, right? See why? You got a diameter, which means this whole big arc is 180 degrees. Any chords that come from that arc form an angle that is 1/2 of 180. Okay? That one's going to take a couple problems, which I've made sure to include today, okay? To make sure you guys got that. Go with me? We really did it. Oh, jeez.
No, we did it.
We did it. Yeah.
We did it. We're done. Yeah, we're good.
We got it.
Hold on. This is the thing. Write this down.
We did it.
Do it.
Last thing. This is the last thing, I promise. I won't even make you do the problem on it.
Okay, I'm fine with
Okay? If a quadrilateral is inscribed in a circle, then its opposite angles are what? Supplementary? Mr. Halls.
Equals 180.
Equal to 180, right? Yeah, they're equal to 180. If you have a quadrilateral that is inscribed in a circle, then that means that the opposite angles are supplementary. And if you would do me the pleasure of writing down that information, we'll be done for today.